So we're going to talk about exponents and all the different attributes of exponents. So we have to remember that really exponents have always been there, but we didn't know about them, okay? Just in the same way that a variable always has an identity, like that 1 being multiplied by it, or has the plus 0 going on with it. Those things are always existing, and we don't always see them. So with exponents, any number raised to its identity, the identity in exponents, is again 1. Everything is already to the first exponent is equal to itself. Okay? So everything is really already at an exponent of 1. We just don't have to write it all the time. Okay? So we have this as the exponent identity. So we have the additive identity, the multiplicative identity, and the exponent identity. Okay? So as we get into each of the different operations, it has an identity that works well with it. Okay? This means that also, just like you can subtract 0, 0 is the additive and subtractive identity. Okay? Multiplying or dividing by 1 is still the identity. Anything to the first root is still itself, right? Okay? We're going to get into roots a little bit and some of the things that we don't write there that maybe we should, especially as we first introduce it. Okay? So we've got the exponent and the identity of 1. Okay? But what is an exponent actually? Okay? So exponents are those little numbers that we write next to something. So x to the squared, right, or to the second power, or 5 to the third power, or 8 to the fourth power, okay? When we're doing this, each of the operations continues to build on themselves for these first 6, okay? Because exponents is operation number 5 and roots is operation number 6. So here, we've got this, and instead of repeated addition, which is a nice way of thinking about multiplication, okay? Exponents is repeated multiplication, okay? So that means that I'm doing x times by x. I've got 2 of them, okay? This top number is telling me how many times I multiply the base by itself, okay? So each of these, the big number is our base, the small number is my exponent. So here we've got 5 times by 5 times by 5. Okay? Now especially as we're doing multiplication of variables like this, using that dot gives it more meaning because just putting them next to each other may not be very clear. So understanding that multiplication comes in the form of an x early on. Then we start using the dot or things just being next to each other that are not like terms. Okay? Here our base being 8, and we've got it 4 times, so it's 8 times 8 times by 8 times by 8. Okay? So that in the basic aspect definition is what an exponent is and what it does. Okay? Now, beyond that, things start to get muddy pretty quickly. Now we deal with exponents, especially in units, as we start dealing with, we may have 24 centimeters squared, okay? Something comes on as early as that, as soon as we're talking about area, okay? So we're really using the exponent very early on without fully understanding it. It doesn't get explained in 3rd grade, because 3rd graders are just getting multiplication under their belt. Being able to jump up to exponents is a little crazy for them, okay? Now, in 5th grade, we get the full explanation of volume. That means I might have something like 24 meters cubed, okay? Because we're dealing with 3-dimensional space, and that's a good enough explanation early on for what these numbers are. 2-dimensional object being measured in 2 different ways, okay? Top, bottom, left to right. Here, we've got 3 different ways, top to bottom, left to right, front to back, okay? And so that number tells us our dimension. It does multiple things, and that's all that the students may be ready for in early introduction of these exponents, okay? So dealing with them and the different ways that they're going to show up. So they're going to have, when you actually give the explanation, they'll have used these. They're going to be very familiar with them. Okay? So exponents in and of themselves aren't really a tricky thing. But dealing with situations when parentheses get involved. Okay? Now this is where that order of operations aspect comes in, and we may think, oh, it's got parentheses, I have to do that first. Well, parentheses only has -4 sitting in it. It's not that I have a whole lot to do with number -4. It's sitting there. It's done. It's as simplified as it can be. Okay? But the exponent here and how the parentheses set up. Because if I think about this, okay, these two have different answers, and that's because of how the parentheses are being set up. Here, I'm multiplying everything, the whole base, everything in the parentheses, by itself twice. So this is -4 times by -4. Okay? Here, without the negative being in the exponent is only being applied to the 4. So I have a negative being applied to 4 times 4. Okay? So if it helps, being able to think about it as -4 and only 4 is in the parentheses. These two are equivalent to each other. Okay? They're meaning, they're interpreting the same thing, and they're showing that to you. So here you can see I've got only one sign. This comes out as -16. This one comes out as +16 because the two negatives cancel each other out, right? And so the use of parentheses in here is a pretty big deal, especially because that's a nice thing about signs. But if I have something like 24x squared y squared, okay? What is actually being raised to the power here? So as they're going to see this later on, how I'm teaching the exponents is going to make the big deal. Is anything being raised to the power in our numbers? 24? Well, no. Technically, you could raise it to the 1 power, but that's not going to change its value. Okay? If I actually expand this out, expanded form, 24 stays the exact same. Okay? Because I'm not working to expand out that number. That's what we call factoring. Okay? Or sometimes you do that expanded form where it's like 20 plus 4. But this would move beyond that. Okay? So now we're looking at expanded form of exponents, where I'm going to, instead of write these as exponents, write them out as multiplication. So I've got x times y times y. Okay? Here are my two x's, two y's. So you see how this is all working out. Okay? Writing things out in their expanded form is huge. It helps so much in understanding so many things of what's going on with exponents. Okay? Some of the exponents out there, when they want to do additional things. So if I have x to the 5th times by x to the 4th. Okay? Whoa, we're multiplying and we've got exponents. Yep. Okay, we're going to layer in all of our operations in here. Just as if this was addition, subtraction, multiplication, division. Okay? It's the same idea. Now we're just adding in additional things to do. Okay? So here, if I really write this out, x times by x times by x times by x. That is my x to the 5th. Okay? Times by x times by x times by x times by x. Here's my x to the 4th. Okay? So each of those are being represented. Seeing it in expanded form, that makes perfect sense. Now I look at it, it's all the same thing happening. The same operations being repeated, multiplication being repeated over and over again. So this comes out to be x to the 9th. Okay? Being able to write that out makes a big difference for being able to see and understand what's happening. especially when we've got something like x squared to the third power. A power to a power. Well, if I can multiply and then multiply, I should be able to do power to a power, right? So, how does this look? The idea behind it, the shortcut is, well, then you just multiply your two powers, right? Here we added our two powers. That's our shortcut version of this. Here we multiply. Why does that even work? Okay? Why is this going to come out as x to the sixth? Okay? So writing this out, think about x squared is x times x. It's telling me that I have to do this 3 times. So I've got x times x, and x times x, and I've got 3 of them. 1, 2, 3. Well, this is all exponents, which is repeated multiplication. Now I can see why that's x to the sixth, okay? If I just teach that shortcut rule and say you're always going to multiply, how do they really get a good distinction between the two? They can back up with how it looks in the expanded form, okay? And that helps out a lot. Now, it works out really well, even as we start working in opposites, okay? So I could have x to the 7th over x squared, okay? Now, thinking about the operation that's going on, if I was multiplying, I would add these together, okay? Well, I'm dividing now. That's the opposite of multiplying, so I'm going to subtract, okay? That means that this comes out as x to the 5th. Like, okay, good, and your students, okay, that's the rule, that's what I'll do, and that may be how you learned it. But is there more to it? Yes, there is. Write this out in expanded form, okay? And it takes some time, but it's worth it to help the students understand. And it's not that every single student needs to see this to fully understand, but it will make a difference for someone. Okay? So, when I do this, I've got 7 on top, 2 on bottom. Anything over itself is 1. So I can cancel these out. And in the end, what am I left with? I'm left with x to the 5th, or 5x's being multiplied by each other. Okay? So this expanded form helps so much in understanding how things work out. Okay? Now, if I had, on the other side of this, x squared over x to the 7th. Okay? Looking at this, it's going to come out negative. And what are you going to do with that? Okay? Because in the end, we get x times x, and x times x times x times x times x times x times x, right? We're going to cancel these out, and I get 2 minus 7 is negative 5. I know how that works out. Can I write a negative exponent? Yes. Yes, you can. I represent this exactly like what I would think to do. Negative 5. Okay? Because the negatives in exponents function and work in a different way than what we may perceive them to. Okay? It has to do with the setup of exponents. Okay? So if we were to take something like 2 squared, right? That's something we all know is 4. 2 times 2 is 4. And we can do higher exponents. Okay? 2 to the 4th, 16, right? And we see a pattern emerge here, that every time that we're moving up, we're timesing by 2, okay? Just like here, every increase of the exponent means another time that we're multiplying by 2. Now, coming down, we're going to move into 2 to the 1 equals 2, right? Because moving up times by 2, moving down is going to divide by 2. So these work out, right? Every time that I reduce that power, I just divide by 2. So what is 2 to the 0? 2 divided by 2 is 1, okay? Now this is an important thing, a nice rule that stands out for us. anytime we have anything to the 0 power, it's going to be 1, okay? So again, any number to the 0 power is 1. Now we can continue on with this pattern because we have all these nice natural numbers, whole numbers. Let's go into integers. 2 to the negative 1. Well, on this side, I'm just taking away 1 each side. On this side, I'm dividing by 2 each time. Okay? So I'm going to take and do 1 over 2. Okay? 2 to the negative 2. This equals 1 over 4. Okay? And I can write these out with the idea about here that they're going to be on the bottom of the fraction. Right? It works out really nicely. Here, relating, that would be like 1 over 2 times 2. That negative is putting something on the other side of a fraction. Okay? And so you can continue on. 2 to the negative 3 equals 1 over 8. And this is true of all numbers, okay? So we know these powers, and that's really nice to set us up for it. So you want to start giving things like, hey, what would 4 to the negative 3rd be? Okay? 1, I've got to know all the powers of 4, and you would probably know 4 cubed. Okay? 4 squared is 16. Times it by 4 again, 64. But because of that negative, it's going to be 1 over 64. Okay? And it's interesting because if we step back into place value and decimals, each of the different things, the different place values is a different power of 10. Okay? So we think about the ones. This is really 10 to the 0 power. That's a 0. Okay? Tens is 10 to the 1st power, right? And hundreds is 10 to the 2nd power, and so forth and so on, right? Each one of these is a bigger power. Now, as we move on the other side of the decimal, because the decimal and the ones kind of play a part as being the middle. It's really right in between here. It's at the ones that things get folded over, okay? So, here we have tenths, right? Sounds like I have a really bad list by the time that I'm done teaching about fractions and decimals. This is 10 to the negative 1, okay? Because anything in here, its place value is something over 10, okay? And we have hundredths, which is something over 100, right? And we're pretty comfortable with that idea because all of our money, all of our coinage is in hundredths because 100 of them make up $1, okay? But this pattern does continue on for each of the negative exponents and each of the place values, continuing on. So this really does ... going out all directions. Okay? And so that's really helpful for us to understand as we deal with negatives. Okay? So negative exponents flip things onto the other side of a fraction. So if I have something like x over y to the negative 2, okay? What that negative means is I'm going to flip everything in the fraction. So the first thing I do is I can rewrite this as y over x. Now I haven't dealt with the squared part yet. I just eliminated the negative. So especially as we like to kind of step by step, we're breaking down that exponent into each of the different parts that it does and what it can help us convert into. Then we can distribute that in. So the distributive property continues to apply because an exponent is repeated multiplication, okay? So here we use the distributive property in its bigger setup about moving down one level, okay, in operations. Adding and subtracting went up to multiplying and dividing. So as we did distribution, we often do that with numbers into something that's adding and subtracting. Okay? Here, I'm one level up. So exponents get applied to each of the things that's multiplying and dividing. Okay? So that means that this is going to be y squared over x squared. Okay? So our order of operations, when we really start looking at the different levels of each of the operations, that helps us to be able to see how even the distributive property applies in here. Okay? So breaking that down, just another example for us, if we have something like x to the negative squared over y to the third. Okay? Something like this, I can't do much with each of those because they've already been applied to their smallest part, okay, the smallest base possible. They're simplified. But I can deal with that negative. Well, after I put the negative and flips it over to the bottom side, what gets left on top? What's still there? What's always there, even when I don't have to write it? Well, I could put plus 0, but really it's that 1 that's the big deal. Okay? Because this movement is about multiplying, dividing, so that's why we do the multiplicative identity. It continues to remain there as we process and work through negative exponents.